Hi guys, welcome to the lecture for Module 1, Lecture 4. Okay. So first, let's recap the little slow and how we determine the throughput rate, capacity, and the demand rate. So if the demand rate is higher than the capacity, what happens? That means, let's say you have a restaurant and you can serve 100 customers per hour, but during the dinner time, let's say 8 to 9 p.m., you have 100 too many customers. So you have 100 customers, you can serve up to 100 customers per hour, but you have 100 too many customers. Some customers will wait, right? And if the demand rate is less than capacity, will customers wait? No, because let's say the demand rate is 80 instead of 120, and your capacity is 100. That means you can serve all those customers coming to your restaurant. So let's look at the throughput rate. In the previous case, when the demand rate is higher than capacity, the throughput rate will be determined by the capacity of the restaurant, because you can serve up to 100 customers, but 120 coming in, but 120 will not come out, right? Because the restaurant can only serve up to 100 customers per hour. So in that hour, only 100 customers will leave the system. So the throughput rate will be 100. But if the demand rate is less than the capacity, in this case, demand rate is, let's say, 80, and your capacity is 100, even if your capacity is 100 customers will not come out, because what's coming in is 80, which is lower than capacity. If 80 is coming in, 80 is going to come out because capacity is 100. So the throughput rate in the second case will be the demand rate, unlike the first case. Okay? I have one example about the inventory build-up diagram to show this phenomenon in a better way. It will clarify the differences. Let's say our restaurant is open from 5 p.m. to 3 a.m. and we serve 100 customers per hour, and we have smooth rate of customer arrivals. So that means we don't have a lot of oscillations, a lot of variability. The demand rate is very smooth, so we're just going to focus on the averages. The arrival rate of the customers is going to be 50 per hour between 5 and 7 p.m. and 9 p.m. till the restaurant closes. But during dinner time, our demand rate is going to be 200 per hour between 7 to 9 p.m. And customers wait even if they are not served immediately. Let's say we are the only restaurant on 100 miles radius. So if customers come to our restaurant, they're not going to leave. So no, we don't have any impatient customers. If they come, they're going to wait because we serve the best steak in town. Okay, we just assume that right now. The first plot shows you the capacity and the demand. So the capacity is constant, 100, as you can see here. If you look at my mouse cursor, so it's like 100 from 5 p.m. to 3 a.m. But between 5 and 7 p.m., our demand is 50. 7 p.m. to 9 p.m., our demand is 200. And between 9 p.m. and 3 a.m., our demand is 50. So what's going to happen between 5 and 7 p.m.? Our capacity is 100, but our demand is 50. Will customers wait? No, right? Our capacity is larger than the demand, so we're okay to serve these customers. So the inventory is going to be, meaning the number of customers waiting, will be 0 between 5 and 7 p.m. Okay? But between 7 and 9 p.m., we have 200 customers coming in, but our capacity is 100. 200 coming in, we can only serve 100 of that 200. That means the leftover 100 will wait. And this demand will continue for 2 hours. If we are making 100 customers wait for 1 hour, how many customers will be waiting at the end of 9 p.m., at the end of 2 hours? For 1 hour, we have 100. For 2 hours, it's going to be 100 times 2, which is 200. So we have 200 customers waiting as an inventory at the end of 9 p.m. After 9 p.m., our demand goes back to the normal demand, which is 50. In this case, we don't accumulate inventory because our capacity, which is 100, is higher than the demand rate, which is 50. But at the end of 9 p.m., now we have a 200 inventory. That means we're going to clean that inventory, right? Our capacity is 100, but between 9 p.m. and 3 a.m., we still have incoming customers, which will be 50. But since the capacity is higher than the demand, we have flexibility to clear out that inventory we accumulated between 7 p.m. and 9 p.m., right? And what will be the depletion rate? 100 minus 50. Because that 100 capacity, half of them will be used for the new incoming customers. The rest of it, which is 50, is going to be used to clean out that inventory that we accumulated during dinner time. So if we clean that inventory, that means if we clean that inventory 50 per hour, how long will it take to clean inventory of 200? So we clean 50 for 1 hour. How long will it take clean 200? 1 for 50. So that means 200 divided by 50, which will be 4 hours. So it will take 4 hours to clean 200 customers that we accumulated between 7 and 9 p.m. Okay? So 9 p.m. plus 4, that means around 1 a.m. we clear out the entire waiting room. And after 1 a.m. we don't have any inventory because our capacity is still larger than the demand. That means there will be no inventory. Okay? This will clarify the difference between the capacity and demand rate and how we accumulate inventory in the systems. So we have 3 different scenarios. The first scenario is if demand rate is less than capacity and there is no initial inventory, inventory does not build up. And the throughput rate is equal to demand rate because the demand rate is less than the capacity. The second scenario, the demand rate is greater than capacity. Inventory builds up at a rate, demand minus capacity, and the throughput rate is capacity because we cannot process things more than the capacity. Even if we have more incoming customers, we cannot release customers more than the rate of the capacity. So the throughput rate is equal to capacity rate. The third scenario is the demand rate is less than capacity and you have inventory. In this case, again, the inventory depletes at rate, capacity minus demand rate, but the throughput rate here, it's important, will be equal to capacity rate because the leftover capacity will be used to deplete the inventory. So our system is going to work with full force. So the throughput rate is going to be equal to capacity rate. Okay? Now let's focus on the process selection. There are 2 ways of classifying the process types. The first way is according to customer interface. The second way is according to process layout. Let's look at the customer interface first. It's either make the stock or make the order. If our focus is standardized product, predictable customer expectations, and economies of scale, our operation structure is going to be make the stock. But if in our product, if the customer's preferences are different, if our focus is flexibility Also, if our product has high margins, then we're gonna have make to order. Remember IKEA versus that expensive furniture store. IKEA is make to stock, but that Bogrets, which sells like $10,000 couches, is going to be make to order. Okay? And desired capability for make to stock is efficiency, because our profit margin is very low. We want to take advantage of economies of scale. The desired capability for make to order is flexibility, because we want to offer higher product variety to our customers because their preferences are different. Because of this, our profit margin is high as well. Okay? The second one is according to process layout. So it's going to be either flow shop or job shop. In flow shop, the resources are dedicated to only one product. It's serial, okay, like the X-ray department, billing. But in job shop, you have a network of activities, and each resource is going to be shared by different products. If you look at the network, product A will be used by both product 1 and product 2. The issue in job shop is the setup time, because if you're using resource A for product 1, when product 1 is done with product A, and if you're going to use the resource A for product 2, you have to retool it, you have to reprogram it, you have to clean the resource A. Okay? In flow shop, products don't share resources. You have a dedicated flow for each product. It's really fast, but it requires a lot of investment. It's expensive. And in job shop, it's flexible and it's easy to deal with, variety. It doesn't require layout change often. Okay? So desired capability for flow shop is efficiency. For job shop is flexibility. Okay? So let's look at the type of process architecture for job shop and flow shop. For product volume, job shop is going to be lower because of the setup change, and the flow shop is going to be higher because you have dedicated resources for each product. Equipment specialization will be high for flow shop because you have a machine or a worker or a resource is dedicated for one product. So the specialization is extremely high. So that machine is only taking care of the product A or product B. The variety in job shop is going to be higher because you have flexibility to change building product 1 to product 2 easily in each product, each machine. Machine setup frequency for job shop is higher. That's the entire definition of job shop, because each machine is shared by different types of machining and products. That means you're gonna change you're gonna set up the machine frequently. The labor skills will be really high for job shop because your labor is going to be dealing with different types of products, so you require a lot of training. The variable cost will be really high in job shop because of the addition of the setup cost, the training required for labor, so the variable cost will be very high for job shop. And if we look at the different types of process types from project, job shop, batch processes, and continuous flow is the fastest one for the flow job, and in the project, it's going to be the most more flexible, and it's going to be highest job shop. And then if you look at the variety is going to get higher when you go from continuous flow to project, but the volume is going to go down from project to continuous flow. Okay? And if you look at the life cycles of the products for marketing and operational decisions, first, when you introduce the product, it's going to be mostly job shop, and then when you grow the sales, it's going to be a batch flow, and when your product matures, it's going to be assembly line, and then because of the life cycle of the product, the operational decisions will decline because of the decline of the sales. Okay? So what we learned from this lecture is you have to match product and process position to competitive and marketing strategy. You must match process to product attributes throughout the entire product's life cycle. This is very crucial for the product's survival in its entire life cycle. This will be the end of the lecture 4. Thank you.